The vastness of space is humbling, almost overwhelmingly so. Every time we look up at the night sky, we see stars, billions of them, scattered across the infinite black void. And yet, despite all of these stars, planets, and galaxies, we are confronted with a haunting question. Where is everyone? For centuries, humankind has been searching for answers. We've wondered if we're alone in the universe or if life exists elsewhere. And with the discovery of thousands of exoplanets orbiting distant stars, the possibility of alien life seemed to grow ever more likely. But still, the silence persists. In 1950, the famous physicist Enrico Fermi famously asked, "Where is everybody? If the universe is so vast and if life is so probable, why haven't we seen any signs of extraterrestrial civilizations? Where are the radio signals? Why don't we hear anything from these potentially advanced alien species?" It's a question that has baffled scientists for decades, and it has come to be known as the Fairmy Paradox. Some believe that perhaps alien civilizations are simply too far away. Others argue that they might be using technology that is too advanced for us to detect, or that they are simply waiting for the right moment to reveal themselves. But what if the answer is more complex? What if the silence is not due to distance, or technology, or timing? What if the reason we haven't found alien life yet is because they are trapped? Imagine this: alien civilizations that evolved on massive rocky planets, much larger than Earth. Planets that are so heavy, so gravitationally powerful, that even the most advanced technologies would struggle to overcome their immense forces. These planets, known as SuperEarths, are abundant throughout our galaxy. In fact, scientists have identified hundreds of them orbiting distant stars. And what if these super-Earths are the key to understanding why we haven't found extraterrestrial life yet? This isn't just science fiction. It's a hypothesis that could explain the silence in the universe. A theory that suggests that alien civilizations might be trapped on these super-Earths, unable to break free or communicate with us, no matter how advanced they become. In this video, we will explore this mind-boggling possibility. We'll delve into what super-Earths are, how their gravity could trap civilizations, and why they might be preventing alien life from reaching out to us. But before we get to that, let's first understand what makes these planets so special, and why they could be a ticking time bomb for any life that evolves on them. Super-Earths are planets that are larger than Earth, but smaller than Uranus or Neptune. They typically have a mass between 1.5 and 10 times that of Earth, which gives them a stronger gravitational pull. This means that the gravity on these planets would be much stronger than what we experience here on Earth. On a super-Earth, a person would feel significantly heavier. In fact, gravity could be strong enough to crush any spacecraft attempting to take off. For a civilization to even think about space exploration on a super-Earth, it would need to overcome these extreme gravitational forces. But as we'll see, that may be impossible. While we often think of Earth as the only habitable planet, super-Earths have the potential to harbor life. They could have liquid water, an atmosphere, and all the necessary conditions for life to evolve. In fact, some of the most promising candidates for alien life have been found on super-Earths, planets that might be in the habitable zone of their stars, where temperatures are just right for life. The sheer size of these planets presents unique challenges. To understand the gravity problem, let's look at how gravity works on a super-Earth. As a planet's mass increases, so does its gravitational pull. On Earth, we're used to a certain level of gravity. We can walk, we can jump, and we can send rockets into space with relative ease. But on a super-Earth, gravity would be much stronger, 1.5 to 3 times stronger than Earth's gravity. This increased gravity has significant consequences for both the environment and the development of any life forms that might evolve there. One of the first problems is that the atmosphere on a super-Earth would be much thicker and denser due to the stronger gravity. This would make it more difficult for spacefaring civilizations to launch anything into space. A rocket that could lift off from Earth would struggle to break through the thick atmosphere of a super-Earth. The force needed to escape the planet's gravity would be much higher, requiring far more advanced technology than we currently possess. Even if alien life evolved on these planets, the sheer difficulty of space travel would likely prevent them from ever reaching beyond their home world. But the gravity problem doesn't stop there. Not only would launching spacecraft be incredibly difficult, but the long-term survival of any life on a super-Earth could be at risk. For example, the strong gravitational forces would place incredible pressure on the bodies of living creatures. Evolution would favor species that are adapted to the planet's gravity, but it might not be enough for more delicate forms of life. In fact, any life form attempting to adapt to these extreme conditions might find it increasingly difficult to survive over time. So, if an intelligent alien civilization evolved on a super-Earth, it would likely be trapped on its home planet, unable to explore the stars or communicate with other civilizations. The massive gravity of the planet would keep them grounded, both physically and technologically. But there's another side to super-Earths that makes them even more perilous for any life that might evolve there: their potential for geological instability. Because super-Earths have a much larger mass, they also have much more intense geological activity. The weight of the planet creates massive pressures inside, leading to supervolcanoes, massive earthquakes, and other natural disasters that could threaten any life trying to survive. Over time, these planets could become unstable, with tectonic activity that creates extreme weather patterns, violent volcanic eruptions, and a hostile environment for life to thrive. These harsh conditions would make it even harder for any civilization to develop the technology needed to escape the planet's gravitational grasp. But this isn't just an abstract scientific idea. Some of the most promising exoplanets we've discovered, the ones that lie in the habitable zone of their stars, are actually super-Earths. These planets may have liquid water, breathable atmospheres, and the right conditions for life. Yet, despite their potential, the overwhelming size and gravity of these planets might be ideal candidates for hosting life, but their immense gravity and geological instability present serious challenges. Even if life were to evolve there, the odds of such civilizations ever being able to escape the clutches of their home planets are slim. Let's explore further. The sheer mass of these planets means that, despite their potential to harbor life, they would likely have extremely intense volcanic activity. These supervolcanoes could cause environmental shifts, rendering parts of the planet inhospitable and disrupting any efforts at long-term survival. The geological forces at play on a super-Earth could be so intense that no matter how advanced a civilization becomes, escaping the planet's gravity and launching interstellar spacecraft could remain forever out of reach. It's not just about the natural disasters, though. As civilizations evolve, their technological advancements would be constantly limited by the restrictions imposed by the planet's gravity. Much like Earth's atmosphere, the stronger gravitational pull would make it difficult for spacecraft to leave the planet, and the time, energy, and resources required to do so would be immense. This could lead to a stagnation in technological development, as the priority would be placed on surviving the harsh environment rather than advancing outward into space. The situation would be further complicated by the pressures of living in an environment that is simply too difficult for most species to thrive. As creatures evolve on such a massive planet, they would have to adapt to extremely high levels of pressure, both in terms of atmospheric density and the strain it would put on their bodies. Even if a civilization could achieve remarkable levels of technological prowess, the physical limits of the planet's gravity could prevent them from venturing beyond their homeworld. Moreover, consider the possibility that a super-Earth could harbor life forms that have evolved to survive in extremely heavy conditions. While these creatures might be able to withstand the intense gravity, they would likely be biologically adapted in such a way that they could not survive in environments with lower gravity, like Earth. This could make the development of interplanetary travel even more unlikely, as any potential missions beyond their planet would face not only technological but biological obstacles as well. This brings us to another interesting concept: communication. If alien civilizations are indeed trapped on super-Earths, communication with other potential life forms beyond their planet would be difficult. The powerful gravity could limit their ability to send signals or detect them from afar. Radio waves might not travel effectively through their dense atmospheres, or even if they did, the signals could be too weak to be detected by us or by any other civilization out there. As we reflect on these possibilities, the silence of the universe grows even more haunting. It is not just that these civilizations may be distant or technologically out of reach. They might be trapped in ways we have yet to understand. Their isolation could be a direct result of their environment, and as such, they could remain hidden from us, unable to communicate, explore, or even reach out. Civilizations that may have once been hopeful to explore the stars and connect with others could be caught in a gravitational trap of their own making. Instead of sending out signals or launching ships into space, they are bound to their home planets, struggling just to survive. Even if they were capable of creating the most advanced technology, the crushing reality of their environment might force them to focus inward, forever confined to the planet they were born on. Could this be why we haven't detected any signals from extraterrestrial civilizations? Could it be that the reason we don't hear from aliens is not that they are out there, but that they are simply trapped on worlds too immense for them to escape? The answer may lie not in the vastness of space, but in the very nature of the planets that may harbor life, and the weight of the forces that shape them. As we continue to search for answers, it's essential to consider all the possibilities. The Fermi Paradox may not be about the absence of life, but rather the unseen challenges that life faces in the cosmos. Super-Earths, with their overwhelming gravity and instability, may be the key to understanding why we haven't heard from our cosmic neighbors. They could hold the answers to one of the greatest mysteries in science: the reason for the silence. The more we learn about these massive planets, the more we realize that they represent a new frontier in our understanding of the universe. While they may seem like places of hope for the emergence of life, they also hold the potential to be cosmic prisons where life forms remain trapped, unable to break free and join the larger galactic community. Ultimately, the search for extraterrestrial life may not just be about finding life elsewhere. It could be about understanding the forces that shape the development of civilizations, forces that could prevent even the most advanced societies from breaking free and venturing beyond the limits of their home worlds. And so, the question remains, where is everyone? Perhaps the answer isn't that they are out there somewhere, just beyond our reach. Perhaps the answer is that they are here, on massive gravity-bound worlds, struggling to survive, trapped by the very nature of their environment. And in the vast silence of the cosmos, they may never be able to reach out to us. No matter how life then becomes even more perplexing when we consider that alien civilizations could be right there, within our reach, yet completely unaware of our existence or unable to contact us. The universe is vast, but it isn't necessarily the distances between stars that prevent communication. It's the nature of the planets these civilizations inhabit. Super-Earths may not just be places where life could thrive, but places where it is trapped, unable to escape, unable to explore, and unable to reach out. This perspective opens up a new understanding of the Fermi Paradox. If we assume that alien civilizations are not limited by distance, but by the physical conditions of their worlds, we begin to see the silence as not a sign of their absence, but as a result of their isolation. While we have long looked to the stars, waiting for signs of life, the truth may be that those who might have been able to contact us are struggling to survive on worlds so hostile and complex that communication with us, or with any other civilization, is simply not possible. In light of this, it's worth considering how we, as a species, might fare if we were to colonize a super-Earth. Imagine Earth, but with several times the gravitational force. Our bodies would be under extreme pressure. Our bones, muscles, and organs would struggle to function, and the very act of walking would require a much greater effort than it does now. For us, the physical strain would be immense, and yet, like the alien species living on such a world, we would have to adapt or risk being overwhelmed by the extreme forces. The infrastructure needed to survive on a super-Earth would be radically different from what we have on Earth. The gravity would not only affect human physiology, but also the materials we use. Buildings, ships, and spacecraft would need to be constructed to withstand the immense pressures exerted by the planet's gravitational forces. Spacecraft, built for launch from such a planet, would need to be far more advanced than what we currently possess, and possibly beyond the capabilities of human engineering for the foreseeable future. The sheer scale of what would be required to escape a super-Earth might make space travel impossible, at least until some breakthrough technology emerged. In this sense, a super-Earth could be a cosmic prison, not just for the life forms that evolved there, but for the very idea of exploration. While Earth's atmosphere allows us to send rockets into space and even land on the moon, a similar feat from a super-Earth would require unimaginable amounts of energy. The cost, both in terms of technology and resources, would be so high that it could be entirely unfeasible. This raises another troubling question. Could any civilization ever overcome the forces of nature enough to escape and make contact with other intelligent species? The truth may be that the vast number of super-Earths that lie in the habitable zones of distant stars, where life could theoretically exist, could be far more likely to harbor civilizations that are doomed to remain isolated, forever grounded by the overwhelming gravitational forces of their own planets. Even more disheartening is the idea that these civilizations, despite possibly evolving technologies we can barely imagine, might be incapable of even perceiving that they are trapped. Their world might appear completely normal to them, their sky filled with stars, and yet they could never break free. The intelligence required to send messages across vast interstellar distances or to develop the technology to leave their planet might be out of reach. A cruel irony for beings who evolved to understand the universe, but whose environment prevents stagnation, may be something we are familiar with in a different context. Throughout human history, progress has often been limited by the technology of the time. We have spent centuries on Earth, developing new technologies to explore our planet and its surrounding environments. But now we are on the brink of exploring other worlds. And yet we know that this next step is fraught with difficulties. What would it take for us to escape Earth's gravity? To colonize other planets? These questions are difficult enough when we consider our own planet, which has conditions that are already suitable for life. But imagine for a moment how difficult it would be if our home planet were a super-Earth. If we were confined to a super-Earth, we might not even be aware of the true scale of the universe. As advanced as our technology may become, it might never be enough to escape the pull of our home planet. We might develop advanced communication systems, but the crushing gravity could limit their range, keeping us from hearing signals from distant civilizations, or even sending signals out ourselves. This scenario becomes even more poignant when we realize that the search for extraterrestrial intelligence, SETI, has focused on detecting signals from other civilizations, hoping to hear a sign of life beyond Earth. However, if the civilizations out there are trapped, just like the hypothetical ones on super-Earths, the silence may be the only thing we hear. It would be a silence born not from absence, but from imprisonment, from a place where life cannot reach beyond its world. Moreover, there is another twist to consider. Even if alien civilizations on super-Earths develop technologies powerful enough to send signals into space, would we even recognize those signals? Our methods of communication, our radio waves, and our detection technologies may not be capable of perceiving signals from such distant and isolated civilizations. Their communications might be so advanced, so subtle, or based on entirely different principles of physics that our instruments simply cannot detect them. This is a disturbing thought, especially when we consider how much time, effort, and money have been poured into SETI and other similar programs. What if we are overlooking something we cannot even conceive? In many ways, our search for life elsewhere in the universe may be asking the wrong questions. Instead of simply wondering if alien life exists, we might need to reconsider the way we search for it. Perhaps the silence of the universe is not a sign of absence, but a sign of trapped life. Civilizations bound by the very planets they call home. If this hypothesis proves to be true, it would mean that the silence we encounter may not be forever. It might only be a matter of time before our technology, or theirs, advances to the point where we can finally communicate. For now, though, we continue our search, asking the same questions that Fermi asked all those years ago. Where is everybody? And while the answer remains elusive, we must consider that those we seek might not be out there in the distant stars. They might be right where we are, struggling to break free of the forces that keep them trapped in their cosmic might be trapped on their home planets is both fascinating and haunting. It redefines how we think about the search for life beyond Earth. Instead of envisioning starfaring empires spreading across galaxies, we are faced with the possibility of intelligent life forms who, despite their brilliance, might be prisoners of their own worlds, surrounded by stars they'll never touch. Let's explore that idea further. Imagine a civilization evolving on a super-Earth, a planet perhaps 5 or 10 times the mass of Earth. Life begins in its oceans, crawls onto land, and slowly develops intelligence. They learn to make tools, build shelters, and understand the world around them. Over thousands, even millions of years, their minds evolve. Curiosity takes root. They begin to look up at the night sky and wonder, just like we did, what's out there? But their reality is different. Everything they build must be heavier, stronger. Their bodies are short, stocky, adapted to a crushing gravity. Their structures are dense and reinforced. Their vehicles are powerful, but limited to the ground. Flight, if it exists at all, is rare, expensive, and risky. Reaching space, nearly unthinkable. On Earth, it takes roughly 9.8 meters per second squared of acceleration to escape gravity. On a super-Earth, that number could be double or triple. That may not sound like much, but it makes a world of difference. The Saturn V rocket, which took humans to the moon, carried about 90% of its weight in fuel just to break free from Earth gravity. On a super-Earth, it might need 99.9% of its mass to be fuel. The engineering challenges quickly spiral into the impossible, unless they discover entirely new forms of propulsion, something beyond chemical rockets. Any dream of reaching space dies on the launch pad. But what if they do have advanced technology? Couldn't they develop nuclear propulsion, or antimatter drives, or some form of quantum tunneling? Maybe, but even those have limits. The energy requirements might be so vast that gathering enough material would take centuries. The precision required might be so high that even a minor miscalculation could destroy the craft. And all of this assumes their civilization survives long enough to develop such technology, without being wiped out by natural disasters, resource scarcity, or internal conflict. It's not just the physics working against them, societal implications. It's history too. A species that can't reach the stars might slowly lose interest in doing so. Generations born under heavy skies might come to believe that space is forever beyond their grasp. Their myths and stories would be different from ours. Not tales of gods descending from the heavens, but perhaps of ancestors trying and failing to reach them. Over time, exploration might seem irrelevant. The stars unreachable. Their science might flourish in some areas but remain stagnant in others, especially those that lead nowhere practical. And if such a civilization looked out into the galaxy and saw nothing, heard nothing, wouldn't that reinforce the belief that they are alone? They might not even develop the idea of extraterrestrial life. Or worse, they might assume all other civilizations are just as trapped as they are, silent, grounded. Now imagine they build massive telescopes, far more powerful than ours. They see planets orbiting distant suns. They see potential, water, atmosphere, warmth, but no signals, no signs of life. Just as we look for them and see only silence, they do the same. Two civilizations separated by light years, both believing they're alone because neither can cry out loud enough to be heard. This mutual isolation could be the universal norm, and that changes everything about how we interpret the Fermi Paradox. Maybe life is common, maybe intelligent life is common, but maybe the ability to leave your planet, to explore, to colonize, to communicate, is incredibly rare. Maybe most intelligent civilizations are like songbirds in sealed cages. They can sing, but no one hears them. Let's return to Earth for a moment. We often think of ourselves as just beginning our journey into space, and it's true, we've only been launching satellites for about 70 years. We've only sent humans beyond Earth's orbit a handful of times. Our farthest spacecraft, Voyager 1, has just barely left the solar system, and it will take 40,000 years to get anywhere near another star. But compared to a civilization on a super-Earth, we're incredibly lucky. Our atmosphere is thin enough for rockets to escape. Our planet's mass is low enough that chemical rockets work. We have easy access to a moon, an asteroid belt, and planets that are relatively close and navigable. In short, our environment is forgiving, and that forgiveness might be rare. It's entirely possible that we were handed a golden ticket, and what we do with that ticket matters. Because if we are one of the very few species with the physical ability to explore beyond our world, then we may also be one of the few who can carry knowledge and maybe even hope to others. Think about the implications. One day, thousands of years from now, if humanity develops near light speed travel, we might reach one of these super-Earths. We might descend into the thick atmosphere, land on the surface, and find a civilization that has waited millennia for someone to arrive. A civilization that thought they were alone, that thought the stars were silent. What would that moment feel like? A first contact not with beings more advanced than us, but with those who never had a chance to leave. And perhaps in the distant future, one of our missions might not just be to explore or to colonize, but to liberate, to help others build what they could never build themselves, to become the messengers of the galaxy. But that will require patience and wisdom. Right now, we are just beginning to understand our role in the cosmos. The more we learn, the more we realize how fragile and rare our situation might be. Earth, for all its flaws, might be the perfect launch pad, and that means we carry a unique responsibility. The silence of the universe shouldn't make us feel hopeless. It should make us determined to reach out, to listen harder, to look deeper, to imagine what life might look like in forms we've never considered. Life trapped under oceans of pressure, life hidden beneath frozen clouds, life that thrives in sulfur storms or in subterranean oceans, or on worlds so massive that even light struggles to escape. This silence may be the greatest challenge we've ever faced. Not because it confirms our loneliness, but because it hints at an unseen tragedy. Countless civilizations blooming and fading without ever connecting. A galaxy alive with thought, but gives us something profound. Purpose. If the universe is full of life that cannot escape its cage, then maybe we are not just explorers. Maybe we are the ones who must carry the light. Not just the light of science or knowledge, but the light of connection, the light that says, we were here, we listened, we found you. That is why continuing our search for life is so important, not just for the thrill of discovery, but for the promise it holds. The promise that one day we might break the silence, not with a message received, but with a message sent. We are not alone, and we're coming, not as conquerors, but as companions. Because maybe, just maybe, the greatest act of intelligence is not to build or explore, but to understand the struggles of those who cannot, and to reach out anyway. So the next time we look up at the stars and ask, where is everybody? Let's remember this. They might be out there, watching, hoping, waiting, and it's up to us to be the voice they cannot be. The silence of the universe is not an absence. It is an invitation, and we have the chance, maybe the only chance, to answer it.